everyone. Welcome to a session that I'm personally very excited about, which is the Innovations in Micromobility Operations session. So we have Arian Marshall who's with us, who actually I'm pretty much just going to hand it over to you, Arian, and you just want to go and run with it, and then I'll jump out, and but I'll be sitting here in the background and just making sure, seeing if I can get Ben back in as soon as possible.
That sounds great. So today we're discussing a cool announcement that all these three gentlemen, once we get Ben back in here, will be able to discuss. First, we've got Dmitry Shevelenko. I think I said his name right.
Nailed it.
Yes, who's the co-founder and CEO of Tortoise. We've also got Tony Ho, who is the vice president of Segway. And now, finally, we've got Ben Baer, who's the chief business officer of Spin. And before we talk, we're going to watch a video.
Oh, wow. It's doing by itself. How does it do it by itself? This is the future.
At Spin, we build city solutions that serve both riders and pedestrians. We're partnering with Segway and Tortoise to provide a mobility solution that helps us keep sidewalks orderly and operate more efficiently. We're thrilled to bring a new Spin S200 three-wheeled scooter to cities in North America and Europe this year.
When making product decisions, we are always considering safety, parking, and compliance as our top priority. Riders less comfortable with a traditional two-wheel scooter will find our brand new Spin S200 to be a more stable and safe experience. The Teleoperations software allows us to remotely operate our fleet of S200 scooters. This means that we can reposition a scooter that is blocking a sidewalk or an ADA accessway. Soon, we will be able to drive a scooter to the customers on demand right where they are.
This scooter is a true win-win for our riders, pedestrians, city partners, and the industry as a whole. It's a real step forward towards the city of the future.
So today, Spin and Tortoise and Segway are announcing that they're combining forces to create this teleoperations pilot in Boise, Idaho. And I'd love to just kind of start out by talking a bit about the problem this technology is trying to solve. Ben, I know you spend a lot of time talking to cities about the kind of stuff they want from e-scooter and an e-scooter share program. What kind of, how will this make life easier for them and the service more appealing to them?
Yeah, so this is a big deal for all of our stakeholders. For cities, parking compliance is a big problem for them. And, you know, for example, in San Francisco, we have a requirement, all operators do, to repark improperly parked scooters within 2 hours. Today, we're at about 54 minutes, which is the fastest of any company. But with this, we can literally do it within seconds. The other big way that this could be a huge unlock is in terms of making scooters a more reliable form of transportation. So later this year, we'll be launching scooter hailing. Imagine you want a scooter out front of your apartment, you know, at 8 a.m. every day when you need it, or at your bus stop. That's going to be possible within the year. And then on the operational side, moving the scooters from lower demand areas to higher demand areas could be a really huge way to make this a service that covers more of cities, and that is a better way to get around within them.
Great, and I should also say, if anyone ever has questions while we're chatting, stick them in the chat. I'll try to actually ask the folks here about it. Dmitry, I know you've experimented with this Tortoise technology in real cities, on real streets before. What are some of the big lessons learned that you're going to bring to this new project in Boise?
Well, what's really exciting, and thanks for having us here, and really excited about today, is this is the first time we're deploying an integrated three-wheel scooter. So in the past, we've launched pilots of our technology using retrofitted scooters, and the Segway and Spin co-developed T60 S200 scooter is the first integrated scooter that works with Tortoise's remote repositioning system. And so that's a big deal. So we have both a first-class product for riders and first-class technology doing the repositioning, and we're doing it with one of the top 5 global scooter operators, and so that's really exciting as well, in a major city as opposed to a smaller suburb. So a lot of great things came together. We're really excited to prove this out in Boise. And as Ben said, that this solves so many of the core challenges in shared micromobility operations that if we get it working well there, we hope to have this everywhere soon.
So tell me a bit about how it works. Tony, I know that it all starts with the physical scooter. What are the sorts of things that you're doing on your end at Segway to make this kind of crazy futuristic technology possible?
Yeah, so what Segway and iBot actually our claim of fame in the industry is really about the scooters, right? We supply to our essentially first generation scooters we supply to all the operators, and especially we have strategic partnership with Spin here, but we always look forward for innovation in the product. So we actually have thought about these things probably 2 or 3 years ahead of time. So that's sort of the beginning of this whole thing when we announced the first ever semi-autonomous scooters at Berlin last micromobility show. But we know it's going to be a long path towards fully autonomy, right? So in this case, this is actually a really exciting time, as Dimitri mentioned. It's actually the first time we have the rubber meets the road in the sense we actually have an actual product on the road. So what happened in the past almost 18 months now is that starting from the concept we demonstrated at Berlin, we start to improve on it. So the product you see on the street now, they're actually sharing scooters. In fact, they even share many components as the similar scooters Spin operates on the street. And actually they have, essentially they're tough, right? So they can sustain the beating on the street. And also we're adding even more things like data and there's a lot more capabilities that's even more practical for the street to, for the city to gather these data for their planning, for regulation, and all these purposes. So we have to keep innovating and keep moving the industry forward.
Dimitri, I know that as Tony alluded to, Tortoise has been very careful to say that these are not exactly autonomous scooters. They're not totally self-driving. There's a cool little solution on the back end as to how they're actually operating. Do you mind telling me a bit about that and a bit about your approach to teleoperations in general?
Yeah, so our view on how we get automation on public roadways is low speed before high speed and remote controlled before autonomous. And so we have a team of trained remote teleoperators, and they're able to just use a basic laptop computer and an Xbox controller, and seeing out of the cameras that are natively integrated into this new scooter, they're able to, at a low speed, drive it from A to B. And so what we do is we build in native routing, so the teleoperator knows exactly where to go, what side of the street to go on, what streets not to go on. So it's kind of like a video game. But one of the reasons we think it's really important to start with remote controlled is when you're going on sidewalks, you're dealing with people. We've got pedestrians, and there's no autonomy software that exists today that can perfectly predict what a pedestrian is about to do. So we think it's really important to be applying human judgment whenever you're repositioning on public roadways, and the data that we're collecting and everything we're doing while we're in remote controlled mode, it will certainly set the stage for turning on autonomy over time, but that's not our focus. We need to show cities that this works well. We think it does, and we have a lot of data behind that. But I think with the benefits that Ben highlighted, the public is no worse for the wear with it being remote controlled or autonomous, right? So the ability to summon a scooter, to repark it immediately, to efficiently recharge it or rebalance it, doesn't matter whether it's remote controlled or autonomous. So that's our approach.
Okay, we have a bunch of very practical questions in the chat section. Guys, just jump in when you have the answers. How quickly do these go? How far are they going to travel when you first get them on the road in Boise?
Yeah, let me address a couple of those questions. So our typical scooter goes about 15 miles an hour. We're expecting the teleops mode to go less than 5 miles an hour. So this is very low speed. And that's for safety reasons. when we were doing field testing, we actually had our CTO stand on the side of the scooter, put his leg out in front, and the scooter stopped instantly because the latency was so low, and you've got real humans looking at what's on the feed in front of the scooter and behind the scooter. And one other point on the data, which we were just talking about. So we actually just found out on this call that USDOT's C2 SMART program approved a grant to the University of Washington Sustainable Transportation Lab to study the effects of this pilot. So we really want to learn through this. We don't know exactly what's going to happen. Tortoise has run some pilots, but this is a new thing. We have to see how riders interact with it. We think the three-wheeled device is going to be appealing to a whole new different group of riders, hopefully older riders or folks who aren't comfortable on two wheels. We have to see how pedestrians interact with it. There's a lot that we have to learn. And then lastly, what's the effect on the business? So there was an MIT analysis about a year ago that estimated that you could get 10 times more trips from the same number of scooters with remote operations, with being able to move them. We need to see if that's true. And we're going to be able to find all that out from this pilot.
Tony, could you tell us a bit about the cameras and the sensors on board and how those work, and maybe Dimitri as well?
In terms of hardware and a sort of lower level software, I sort of describe it as almost like a cell phone on two wheels, right? So you have a camera on top of them. So I actually want to echo what Dimitri was saying, is that we ultimately we want to call them, the buzzword is autonomous driving, but it's actually really not. It's really just a smart scooter, in the sense that you still have human to drive them, but you actually use sensors and those things to facilitate and to help you to drive. For example, this scooter actually has this obstacle detection mode, right? So if you have somebody right in front of it, actually there's a little sensor detect, oh, there's a person in front of me. And in fact, the camera actually detects there's a person in there too. And so a lot of these things happen without sending these images back to the server. So in other words, there's actually really no data was kept on the server. Actually the driver probably can watch it, but in terms of the machine itself, it's just using the machine vision algorithm to detect these features, the pedestrians, the roadblocks and whatnot. So we basically, this is sort of the sensory part. Then once the machine, actually the scooters sees there's no problem, then the operator, of course, will have to do the remote control thing, right? And at a certain time, if there's emergency brake, then it's a little bit like today's
driver assist.
Cars, driver assist. That's a good analogy. Yeah. And then Dimitri can talk a little more on your side, on teleoperation side. Yeah. How it works.
So it goes over 4G networks. There's some questions around that, and that's one of the why is this possible now? Well, in most places where you have shared scooters in the U.S. and Europe, you have pervasive 4G connectivity. One of the things our system does is constantly check the latency and the connectivity in an area. And if we start noticing the connectivity is declining, we'll route around and go a different area. Routing optimization is one of the big technologies behind our system. So if we go down a certain sidewalk and it takes us a while because it's really bumpy or there's a challenging environment, we'll not go down that sidewalk again. And so those are the sorts of optimizations that keep getting better with every trip we do.
We have a bunch of questions about labor costs, Ben. And I'm especially interested in how Spin is thinking about this in light of the fact that maybe about a year ago, you announced that you were using W-2 employees rather than independent contractors or gig workers to do a lot of your scooter replacement, moving around. How does this kind of pencil out for you right now to have this teleoperation solution?
Yeah, so the effect on labor costs is something that we're hoping to learn from the pilot. One thing to note is we still are going to have and always have our W-2 full-time and part-time employees out in the field that are running our operation. What we're really excited about this with is incremental reparking. So being able to repark a scooter that's hard for our staff to get to. It doesn't make a lot of sense to send one van out with an employee to go and move a scooter 5 feet. And so that'll be a big savings that we don't really have a sense for yet. And then incremental rebalancing. So, one challenge that scooter operators have is that although we'd love to rebalance often throughout the day and make sure that there's always a scooter when you get off the train or you get off the bus, that is very expensive. So we end up rebalancing only once or a couple times a day maximum in markets. With this, we can be looking at demand in real time and rebalance constantly. So we're paying for those incremental rebalancing costs through Tortoise through the increased trips, but there's not really a decrease in staff usage that is associated with it.
Tony, talk me through the, I believe, Ben, correct me if I'm wrong on this, but I believe this is Spin's first three-wheeled scooter. Talk me through the kind of form factor here and the decision to have 3 wheels instead of 2.
One of the things you notice, especially, there's a lot of these pictures like Bird's Graveyard or something like that. And you actually always see these dominoes, right? Scooter dominoes. One of the things inherent about scooters is actually they're 2-wheelers. So the problem is actually this early on is customer approach us saying, can you actually make them self-balancing because we're Segway, right? So we scratch our head and say, I don't think that's possible for the 2-wheel scooters. But there's something called 3-wheeler scooters. So that's how we started. We're saying, hey, inherently 3-wheeler will be stable. And because if you think about the first vehicle a baby has is a 3-wheeler kick scooter, right? So the learning curve can be even lower for I think as the video says, and we actually see some more older generation probably prefer something more stable, right? So I think that will lower the entry barrier and is serving a different demographics. So naturally we designed this. And in fact, we actually use this as one major measure for 3-wheelers. And there's another product, it doesn't have the smarts, it's actually called G60. It also have that feature, and obviously it's cheaper because it doesn't have the computer in there. But the T60 is just sort of the, almost like the autonomous feature almost catch people's attention, even though it's not as practical as the 3-wheeler G60. And I believe Spin actually has some of those as well. And one of the experiments we did is we actually have people kicking them. And we're purposely kicking the handlebar. And they didn't fall until like you get to like 45 degrees and it's almost lean over. And then so really you have to purposely to do these things, as opposed to people playing scooter dominoes. They would just hit one and everyone there will go, right? And you will not see that kind of domino effect on the 3-wheelers at all.
Yeah, and that also addresses one of the most common questions we get, which is, well, what happens if if somebody sees a scooter going by them on the sidewalk and they push it over? With the front suspension on the scooter, you're going to have to push really hard. But this is also one of the reasons why, as Ben was saying, Spin has dedicated W2 employees in every market they're in. So if we ever have an incident where we're not able to successfully complete a remote repositioning, Spin's team knows in real time because one of our teleoperators notifies them, and they're there soon to help the scooter get on its way.
Yeah, Dimitri, I think that is also always the first question I hear about this kind of technology. What do you happen when someone just decides to wail on it? I know you were running scooters in Georgia for a while. Was that a problem that came up a lot? Did people go after them?
No, people are I think we don't give people enough credit. And I think what's also obvious to people who are on the sidewalk is there's cameras on these things. And so unlike I'm going to call them a dumb scooter, but the scooters we have today, you push one over, the likelihood that anybody will know you did it is zero. Whereas I think people are more aware that, hey, somebody might notice that I'm the one who did it. So we've been very pleasantly surprised. The issues we had in other pilots was less anything that people were doing. It was more the form factor because we were retrofitting, and that wasn't as balanced a scooter as the S200 is.
It's good to hear a positive message about humanity.
And we also, and just to kind of add to that, the other part of our business is we have our own remote controlled delivery carts that we're live in LA and Miami with. And that's also the #1 question I get is like, do people try to steal things out of them? And so far we haven't had a single attempted theft. So, humanity is doing better than we give it credit for.
That's great. Another question for you, Dimitri, and Ben, I'd also love to hear your thoughts if you want to chime in here. We got some questions in the chat about regulations. Is this something that city or teleoperations, something that cities and states are trying to make easier for you? Is it something you have to go in and get new laws passed or new codes passed? How is that working out right now?
Yeah, so one of the things we were worried about when we first started engaging with Tortoise and Segway on this was cities are going to be freaked out, they're going to be scared. The reality is that there's a lot of very tech-forward cities that want to be first on new things. E-scooters are now in a place generally where it's not a question of should we have them or not. It's how do we make this a sustainable long-term part of the transportation ecosystem and serve all the customers that we want to serve that don't have access to a car. And cars have an average selling price of $40K last year in the US. And so we found that there were already over 15 cities where we were eligible to do this in the United States. My theory, and Dimitri probably knows more about this, is that some of the delivery robot companies have been having these conversations for 3-4 years now. And so they've really opened up the pathway for teleoperations to move faster. Cities like to fast follow. So in addition to the cities that are comfortable with it now, if it works really well and it increases accessibility and reliability and makes the sidewalks and streets clear for disabled folks, then it'll move very quickly from what we've seen in the scooter boom.
The thing worth remembering is this technology solves the #1 complaint cities have about shared scooters, which is sidewalk clutter and obstruction, right? So and I think the fact that we're solving a real problem, coupled with the low speed and remote controlled technology. When I say remote controlled to city officials, it feels like I'm talking about a Radio Shack ad from the 80s, not something that you're, and that's great, right? That makes people feel comfortable with the technology, and that's critical to regulatory adoption.
We've got a question about Boise is not Los Angeles. Tony, how are these 3-wheeled scooters working in the snow, in winter conditions?
Well, we're about to find out, right? But then the interesting thing here is that 3-wheelers are incredibly stable. And also because they have 3 wheels, so they have better tractions. So we actually do have high hope they will actually ride better. And also, I think the important thing is that the difference here is not the scooter itself. It's more about the smarts now we're adding into this. So, and also what are the possibilities? I think, in fact, beyond just the navigation part, there's actually, we find there's so many things you could do, right? So, for example, we even look at the vision system, say, how can you actually use those vision system to tell people whether they're driving on the sidewalk or on the motorway, on the road, and those things can be common not just for the 3-wheelers, it could be for 2 wheels. In fact, we actually have a new product launching, announcement coming up too, is actually a 2-wheelers with the same smarts. So it's just really about sensors and IoTs, and how do they meet the need for the cities and make essentially this part of the smart cities movement. Yeah. So I guess it's probably not necessarily the weather conditions, but also kind of really helping the overall infrastructure. That's what we are kind of focusing on.
I am wondering about how you're thinking through, even if these things aren't getting beaten up, they're going through the wear and tear of living on the streets. Tony and Ben, how are you thinking through repair for these things, especially given all the, expensive tech on here, the sensors, the cameras?
Yeah, I mean, so our team in Boise is going to be trained specially to work with the S200 scooter. And, we're going to learn a lot through that process as well. We already have scooters with cameras out prepping to go into the field using what we call Spin Insight. It's similar to what Tony just described, using the camera to sense whether you're on the street or the sidewalk. And that works today. And we haven't had a ton of issues in field testing for that. But it's going to be yet another thing that we'll learn. I hate to keep saying that, but given how autonomy and related issues have developed in the world of cars, there's just a lot we don't know. But the exciting thing is we're going to find out, in the next couple months, and we're going to have scooters going to customers this year. So it's possible today.
And to add to what Ben was saying is that sometimes we're adding complexity, but the thing is the complexity gives you so many new opportunities. So for example, because there's a lot more computing power on essentially on edge, you can actually do more remote diagnostics and you can even see what the problems are, as opposed to before you just don't know what's going on in the field. So that, like I said, the same technology applicable to three-wheeler, two-wheelers. Well, I don't know, maybe there's other form factors too. But in terms of maintenance, repair, not only it reduces the chances of things getting broken easily, but also it will kind of facilitate the whole remote diagnostics type of activities, and will essentially improve efficiencies. Yeah.
The example I like to use is if we can just get all of the scooters away from the bars when it's last call, that alone will significantly reduce vandalism and accidents, right? And so now we have this remote repositioning solution, and so we can avoid having scooters be in the locations where historically they've been most likely to be damaged. So there's a whole new world of operational flexibility.
I'm now obsessed with the idea that you'll see the scooters fleeing the downtown bar scene at like 8 o'clock. So we've been talking, Ben. I'd love to hear from you, and I'm sure other folks will have things to say as well. We've been talking about what cities want from companies like yours, but what would you like to see from cities? What is the kind of infrastructure that would make this a safer, preferable alternative for people who are maybe commuting by car right now?
I mean, our rallying cry has always been protected lanes. And fortunately, cities across the world really see exactly the same vision. There's this big movement towards creating 15-minute cities, better infrastructure for bikes, scooters, and now remote-controlled teleoperated scooters and delivery robots is essential. And so I think you'll see those sort of third and fourth lanes start to emerge. And we really need that for this to work well in dense urban areas and for it to.
Dimitri, does that sound right to you?
Yeah, and I think more than anything, we want cities to embrace doing things that are a little bit different. And I think we can't keep repeating the same playbook and hoping for magical solutions to things like sidewalk clutter. And so I've been in this space very pleasantly surprised how many entrepreneurial folks work in city offices, and we need to find those champions and empower them.
Tony, I know you work with cities all over the world. Are what cities in different places? What are the big priorities you're hearing?
Oh, they are so different that it's almost impossible for us. That's one of the reasons we love to partner with Spin and Tortoise, because literally they are on the ground and as product companies, we listen to our customer, right? And of course, it benefits us tremendously if we communicate with certain cities who are thought leaders in the space, like Boise, and basically we kind of working hand in hand with them on like standard setting and making sure there's safety standard in place, and also sharing data as well, right? So both from vehicle point side and also from user side and from the operators, and so essentially we can build to the requirement as opposed to we kind of inventing the wheel in our own lab. So that is valuable for us to have a really open dialogue and continuous dialogue.